Hello grade 10 students. Today I am here to teach you chapter 20 in your textbook that's called Logarithms II. We discussed Logarithms 1 in chapter 19. We'll see more about logarithms in this chapter. So before we start logarithms, we'll see what is scientific notation. So we'll take any number and trying to put that number in between 1 and less than 10. So I'll write in 3 decimal places 1.0002. Less than 10 I can write as 9.999. Correct to 3 decimal places. So what we are trying to do, any number we are trying to put in this range. That's called scientific notation. We'll see how we can write down numbers in scientific notation. Look at these examples. 24.6. Is it less than 10? No. So we are trying to write down this number in between 1 to 9.999. So what we can do, what's the number less than 10? 2.46. But we can't write 24.6 as 2.46. How can we get 24.6 from 2.46? We have to multiply this by 10. So I can write without just write 10 to the power 1 because 10 to the power 1 is 10. So this form we call scientific notation. Now try to write down this number in scientific notation. Here the decimal place is here. What's the number less than 10? Is it 41.83? No, the number is 4.183. How we get that number? Using this one here. Look at the decimal place. 1, 2. 2 places to the right. So that means you have to multiply by 100. So 10 to the power 2. Look at this number 6,275. What's the number less than 10? 6.275. 10 to the power. How many places you are moving? Now the decimal place should be here. 1, 2, 3, 3 to the right. 10 to the power 3. Now try this number. What's the number less than 10? Already this is a number less than 10. So you write as it is. That means we are not changing the decimal place. So what's the number? You are just multiplying by 1. Multiply by 1 is 10 to the power 0. Now you get a decimal value. How can we write down in scientific notation? Now look at this one. 0.7 is less than 1. We need less than 10 and more than 1. What can we do? We have to move 1 decimal place to the left. Then what happens if it's moving to left? The power becomes negative. So here we get -1. Now try this one. Moving this decimal place 2 places to the left. 9.87 into 10 to the power -2. Try this one. 1 place to the right. 8.747. 10 to the power 1. Here, how many places? Count. What's the number less than 10? 3.4. From here, 1, 2, 3, 4. 4 places to the right. 3.4. 10 to the power 4. Now last one. a decimal number. How many places? 1, 2, 3, 4, 5 places to the left. So what's the number? 8.0 times 10 to the power minus 5. So look at carefully. You can see when the number is a decimal value, the power becomes negative, and if it's a big number, power is positive. So all these numbers are more than 1 and less than 10. Now in chapter 19, we did about logarithms laws. This is index notation. 36 you can write as 6 squared. How can you convert to logarithmic form? How can we convert to logarithmic form? Log. This is the base, this is the index, and this is the number. So where we write the base we write here, and then the number is equal to the index. Index is 2. Now try to write down this one. 512 is 2 to the power 9. Can you write this in log notation? Log. What's the base here? Base is 2. And the number is 512 is equal to the index. That's equal to 9. Now try this one. What's the base? Base is 10. Log 10 base. The number is 1000 is equal to 3. When you have given the logarithmic form, you can write down the index notation as 6 squared is 36. So this goes both ways. You can write log notation with index notation as well as index notation with the logarithmic form. So both ways it's true. So remember, in this lesson, you need to know how to write in logarithmic notation as well as index notation. Now look at these numbers. 1000 we can write 10 to the power 3. 100 is 10 squared. And when it's a fraction, you can write it as 10 to the power minus 1, minus 2, minus 3 like that. So when you take this table, and we'll try to write down all these in log form. What you get? Log, base is 10. And the number is equal to the index. Here, log 10 base, 100 is 2. Now try all these numbers. You get log 10 base 10 is 1, log 10 base 1 is 0, (1 over 10 is minus 1, this one is minus 2, and last one we can write as 1 over 1000 is equal to minus 3. Now look at carefully. You can write this way also. So this is true for the other way around as well. Now when you look at the logarithmic value, what's the easiest way to remember? When you get tens, what happens to the logarithm? 3. 1, 2, 3 zeros. Here you get 2 zeros, 1 0, and here no zeros, that means nothing. Here in the denominator you get 1, so that becomes minus 1. 2 zeros in the denominator, minus 2. So we can see when you get tens, the logarithmic value is the same as number of zeros. So just count how many zeros are there. You get the number. So we can, that's the important result. We can see the logarithmic value is number of zeros. Only when you get tens. Now we'll try to find out logarithmic value of a number. We know 1 is 10 to the power 0. And also 10 is 10 to the power 1. How can we write down any number in between 1 and 10? Any number in between 1 and 10, it should be 10 to the power of a value in between 0 and 1. What are the values in between 0 and 1? Those are decimals. So definitely this should be a decimal number. Now how can we find out those numbers? One of the mathematicians called Henry Briggs created a table to show the logarithmic values. Who's the mathematician? Henry Briggs. So he created a table called log tables. So we call those are log tables. What we can do using these log tables, we can find out logarithmic value of any number in between 1 and 10. Now we'll see how we can refer the log tables. Now when you look at log tables, first you have to find the log table. Where you can find the log table? In your textbook, last 2 pages, you get 2 tables like this. We'll see. You get in the first page something like this, 10 to 54. And the second page you will get numbers from 55 to 99. And what are these other numbers? All these digits are there without any decimals. Now when you refer this 10 to 54, actually this is not 10, 1.0. 11 is 1.1. So what is 54 means? 5.4. Then starting from 55, 5.5. The last number is 9.9. So what are the numbers here? 1 to less than 10. Numbers are there. So here in the first column, we say this is correct to first decimal place. I'll write first decimal from the first column. So here 1.0, 1.1, 1.2 like that. Here 5.4. When you take the other table, this is 5.5. 5.6 like that. What's the last number? 9.9. These numbers correct to one decimal place. Then if you want the second decimal place, we refer from these 2 columns. So here these 2 columns 0, 1, 2, 3, 4. From this we can refer the second decimal place. Then this column, these 2 columns represent the third decimal place. Now we'll take any number. Okay, 32. What it means? 3.2. So here if you refer this row and this column, what is this value? This means 3.16. If you want another decimal place, you have to refer from this column. So if I say I want to refer 3.165, 3.165. So how we do? 31 and then 6 from this column and 5 from this. So 5 is 7. So what's the logarithmic value? 4997 is 31/6. 4997. And 7 is for the third decimal place. So you just add these two. So when you add, you get 5004. That's the logarithmic value for 3.165. So how can we write down the value? We can write down as, I'll take here. So we found the log value is 5004. So if the number is 3.165, I can write down the logarithmic value is 5004. That means all these are decimals, not whole numbers. I can write this one as 10 to the power 0.5004. So that's the logarithmic value for this number. Then I can write, converting to log notation, log 10 base is equal to, the number is equal to 0.5004. So this is how we can refer the tables. There are no decimals in the table, but you need to know first column represent the first decimal place, the second and third columns represent the second decimal place, and the other two columns represent the third decimal place. Now we'll take several numbers and try to find out the logarithmic value. 2.46. So what we do? We refer 24/6. So that's less than 54. That means you have to refer the first table. 24/6. So take the row 24 and then refer the second decimal place, that's this column, 6. What's the value? 3909. 3909. Is it 3909? No, that's a decimal value. So we can write down this one as 10 to the power 0.3909. Then how can we find out the log value? Log 10 base, the number is this one. So 0.3909. Now try the next one. 2.463. Now there's a third decimal place. So same as before, 24/6 is this number, and then refer the third decimal place, that's 3. So when you take the third column, you get number 5. So we need to add 5 to 3909. What you get? 3914. So what's the value? 10 to the power 0.3914. So that means in log notation, log 10 base number is the index. That's the logarithmic value, 3914. Now try the next one. 5.742. That means more than 54, you have to refer the second table. So what's the number we have to take? 57, 4, 2. Now try that one. Keep a ruler. 57, 4, 2. 57th row is here. Keep a ruler. 4 is this value. And what about 2? 2 is 2. So 7, 5, 8, 9. 7, 5, 8, 9 and add 2 to that. 7, 5, 9, 1. So we can write this one as 7, 5, 9, 1. 10 to the power. So what's this number? 10 to the power 7, 5, 9, 1. So what's the logarithmic value? Log 10 base the number is equal to logarithmic value 0.7591. We'll take some more examples. 7.683. Which table we have to refer? The second table, 7683. 76 is this one. 8 is this value. 76, 8 and the other one is 3. 3 is 2. So that means you have to add 2 to that. 8854 plus 2, that means 8856. So how can we write down the number? This is equal to 10 to the power 0.8856. Then what's the logarithmic value? Log 10 base 7683 is equal to 0.8856. Now what happens here? 24.63. Can we refer 24.63 from the table? Only table gives a number between 1 and 10. So we have to write down 24.63 as less than 10. How can we do that? Scientific notation. So here, first thing you have to do, convert this number to scientific notation. So 2.463, 10 to the power, 1 place to the right, 10 to the power 1. Then what you do? You can refer this one from the table now. 2.463. 2463. Refer the first table. 2463. 24 6 and 3. 3 is 5. So 3909 plus 5. 3909 plus 5, you get 3914. So what's the number? 0.3914. I can write this number as 10 to the power 3914 into 10 to the power 1. Same way as different powers multiplication, you add the powers according to index laws. So what we can get? 1 and this one adding 1.3914. Then what's the log value? 10 base 24.63 is equal to 10 to the power 1.3914. Now look at this number 512. You can't refer from the table. Convert to scientific notation. What's the number? 5.127, 10 to the power 2. Now refer the table for 5.127. 5127. 5127 from the first one. 51, 2 is here, and what's the next number? 7. So I'll mark it 51, 2 and 7. 7 from this column. So you get 6. 7093 plus 6. You get 7099. How can we write down now? This number is 10 to the power 0.7099 and here power 2. Then same base, different powers multiplication, you add the powers. You get 2.7099. Now these are the values we found before. If the number is 2.46, we found this is 3909. Now, what's this LG means? LG is the short notation for LOG 10 base. So, no need to write LOG 10 base. We can straight away write down LG. So, these are the logarithmic value we found before. Now, when you look at carefully, we can write down the numbers at once. Now here, when you look at the scientific notation, what's the power of 10? This number is less than 10, so 10 to the power 0. 0 here. Here also 0. Here also less than 10, 0 comes. This is also 0. But look at this one, 24. That means 10 to the power 1. 1 comes here. This one 10 to the power 2. 2 comes here. This one 1, 2, 3. 10 to the power 3. You get 3 point. So in this table, you can straight away see how we can write down the first digit. That's the whole number. By looking at the power of 10. This is based on the power of 10. When you write in scientific notation. So we call this one as a characteristic. The whole number we say that's the characteristic of the logarithmic value. Characteristic. Then what you call the decimal values. These decimal values you refer from the table, log tables. That's called the mantissa. So how we get the characteristic? Using the scientific notation, and how we get the mantissa? Using the log tables. So straight away you can refer 24.6, get the mantissa value. 24.63, that's the mantissa value. But the whole number from the scientific notation, that's called the characteristic of the number. Now we'll try to write down these logarithmic values at once. So first number, now can you see all these? The log value, the mantissa should be the same because 6953. Always we have to refer 6953. But depend on the scientific notation power of 10, you get the different characteristic. Now look at the first one. What's the characteristic? 69 means 10 to the power 1. So you are getting 1 point something. Here, how many places to the right? 2 places. 2 point. This one, 1, 2, 3. 3 point. Here, we don't have to change the decimal place. 0 point. 1, 2, 3, 4. You get 4 point here. 1, 2, 3, 4, 5, 6. 6 point. Now, how we get the mantissa value? 6953. Which table? The second table. 6953. So, refer the table. 6953. 3 is 2. So, you need to add 2 to that. 8422. 8422. You can write down here. 8422 is the mantissa value. So, all these values, same number you have to refer from the table. You get mantissa value, the same thing. Now, it's easy to refer the table. Look at the power, that becomes the characteristic. Look at the table and get the mantissa value. Finding the number when logarithm value is given. Now, this is the other way around. Earlier we got the number and we found the logarithmic value using the log tables. Now the log values are given and you are asked to find out the number. So we call this is anti-log, the reverse process of finding the logarithmic value. Now we'll see how we refer that. So this is the characteristic. That means how many decimal places you move to the right if it's positive value. The mantissa value is 8347. So you have to look at the table and see where you get 8347. In the first table, the maximum is 7396. So that means you have to refer the second table. 8347. Where you get 8347. Look at carefully. Now the other way around. Here you have to find 8347. 8344 is there. So to get 47, you need another 3. Another 3 you can find from here. So that means 6834. 6834. 6834. Now, how can we decide the number? Look at the characteristic. 0 means that number is less than 10. So, we have to put the decimal place here. 6.834. Now, here same mantissa. You get 6834. But the characteristic is different. You get 1. That means you move 1 place to the right. The answer is 68.34. So here same mantissa, so you get 6834. Look at the characteristic. Characteristic is 2. That means move the decimal place 2 places to the right. So 683.4. This one same mantissa, you get 6834. The characteristic is 3. 1, 2, 3. So the number is 6834. So now we know when you have given the anti-log value, you can find out the number. Now we'll try to use the tables for these anti-log values. 3559. You can refer from the first table 3559. Where you get 3559? 41 is there. 60 also there, so one more than that. But we'll see whether we can find exactly 59. So 59 minus 41, we need another 18. Where we can get 18? Here only 17 we can find. So that's 22, 6, 9. 2269. So we can write that's the anti-log value 2269. Then this is 0 point. That means that should be a number less than 10, 2.269. The next number, same mantissa. That means we have to refer 35.3559 from the table. You get the same value, 2269. The characteristic is 1. Move 1 to the right, 22.69. Same mantissa, you get 2269 for all these numbers. But depending on the characteristic, you have to move the decimal place. Here, 2 decimal places to the right, 1, 2, 226.9. 3 decimal places to the right, 1, 2, 3, 2269. Here, 4 decimal places to the right, 1, 2, 3, 4. You need to put a 0. So, this is how we can find out the anti-log value from the tables. Now, again, you have given the logarithmic value and you are asked to find out the number. So, that's the anti-log value. 0.8157. So, 8157 we'll see from the second table where we get 8157. 8156 is there. We need another one more. Lowest value is 1. 6541. 6541 is the anti-log value. 6541. All these mantissa values are the same. You get 6541 for all these. And you need to just check the characteristic and find out where you keep the decimal point. 0 point means the number less than 10. 6.5. 1 means 65.41. 2 means 1, 2. 654.1. 3 places to the right, 6541. 4, 1, 2, 3, 4. 5, 1, 2, 3, 4, 5. So that's how we find out the anti-log value. If the anti-log value is given, you can find out the number. We'll look at example 1 in your textbook. Find the logarithm value of each of the following numbers using the logarithms table. Indicate the relevant index form too. 6.85. So this is normal log value. 6.85 you can write as 68. You can refer the table as 68.5. So 68.5. 8357. 8357. 8357. Here 6.85 is equal to 10 to the power 0.8357. Then they want the logarithmic value. Log 10 base 6.85 is 0.8357. Next one, 3.4. Number less than 10. 34.0. Refer the table. 34.0. 5315. So we can write 5315 for 3.4. Then LG. I'll write LG instead of log 10 base. LG of 3.4 is 0.5315. Third one, 8. That means 8 is 0. 8 is 0. So 8 is equal to 10 to the power. 8 is 0 is 9031. 9031. 9031. So LG8 is equal to 0.9031. Now we'll look at exercise 20.1 in your textbook. Using the logarithms table, find the logarithm of each of the following numbers. Indicate the relevant index form to 7.32. 7.32 you can write as, you can take as 73 2. 10 to the power 73 2. 73 2 is here 8645. 8645. Then we need to find out the logarithmic value. Log of 7.32 is equal to 0.8645. This one, 1.05 means 10 5. 10 5 from the first table. 10 5. 0 2 1 2. 0 2 1 2. Then LG of 1.05 is 0.212. This one, 9.99. That's 10 to the power 99 9. 99 9 is 99 9 here. 9996. 9996. So here you can write down LG of 9.99 is equal to 0.9996. 5.8. So 5.8 how can we write? As base 10, 58 0. Take the second table, 58 0 7 6 3 4. 7 6 3 4. 7 6 3 4. So LG of 5.8 is 0.7634. All these numbers less than 10. So you are getting 0 point something as the 0 is the characteristic. 9.2, 3.1, 4, 7. All these numbers less than 10. So the characteristic is 0 point something. So we can write 9.2 is 10 to the power 0 point. 3.1, 10 to the power 0 point. 4 is 10 to the power 0 point. And 7 is 10 to the power 0 point. 92, 1. 92, 0. Here 9.2 means 92, 0. 92, 0. 9638. 9638. Then this one, I'll do this one because we have to refer the second table. This is 70 0. 70 0 is 8451. 8451. Now I'll look at this table. These two numbers less than 54. 31 0. 31 0. You get 4914. 4914. And I'll refer 40 0. 40 0 is 6021. 6021. So those are the logarithmic values. So I can write LG of 9.2 is 0.9638. LG of 3.1 is 0.4914. LG4 is 0.6021. LG of 7 is 0.8451. Now here 1 is there. Easily write down this number. 1 means 10 to the power 0. So what's the log value? LG of 1 is 0. You don't need a table for that. This one 1.05. So less than 10. So you are getting 10 to the power 0 point something. 10, 1. 10, 1 is from the first table 10, 1. 0, 0, 4, 3. 0, 0, 4, 3. So what's the LG number? LG of 1.01 is 0.0043. Example number 2. Using the logarithms table, find the logarithm of each of the following numbers and then write each number in index form. So what's the first number? 1.099. You can write down using the log tables. LG 1.099 is equal to 1099. You need to refer 1099 from the first table. 1099. You have to add 37 to 037437. 0411. So you get 0.0411 as index notation. I can write 10 to the power of 0.0411 is 1.099. Look at the next one. 5875. 5875. We need to refer the second table. 5875. 58.7 is this value and 5 is 4. So adding 86 plus 4, 90. 7690. 7690. So what's the power? 10 to the power 0.7690 is 5.875. The next number is 9.071. 9071. 9071. 97. 1 is 0. So 97. 95. 95. 76. 95. 76. So what's the 10 to the power 0.9576 is equal to 9.071. Exercise 20.2. Using the logarithms table, find the logarithm of each of the following numbers and then write each number in index form. So all these numbers less than 10. So you can write LG 1.254 is equal to 1254. 1254 from the first table. 12, 5 and 4 is 14. So you are adding 14 to 0969, adding 14. 9 plus 4, 13, 1 remaining. 7 plus 1, 8, 0, 9, 8, 3. The number is 0, 9, 8, 3. Then you can write 10 to the power 0 0.983 09. 0983 is equal to 1.254. Next one. 3752. 3752 from the first table. 3752. 2 is 2. 5742. 5742. So the logarithmic value we can write. Logarithmic of 3, this one is 0.5742. Next one, 2837. 2837 from the first table. 2837. 7 is 9. Here 2837. 37 is 11. So 4518 add 11. 4529. So I can write here 4529. So LG of 2.837 is 0.4529. Now look at these ones. All these numbers less than 10. I can write 10 to the power 0. 80, 30, 80, 3, 2, 80, 3, 2. 2 is 1. 90, 48. 90, 48. 99, 98. 99, 9, 8. 8 is 3. Add 3 to that, 9999. Next one, 7543. 7543. 3 is 2. Adding 2 to that, 8776. 8776. And then you can write down the log values. LG of 8.032 is 0.9048. LG of 9.9998 is 0.9999. LG of 7.543 is 0.8776. Example 1 in your textbook. Find the logarithm of 54.37. So here we'll use two methods. So we'll use laws of logarithms first. 54.37, how can I write? I can write in scientific notation 5.437 10 to the power 1. According to laws of logarithms, multiplication inside becomes addition. LG 5.437 plus LG 10. What's LG 10? That's 1. 10 base 10. What's LG 5.437? 5437. 5437 is 7 is 5. 7 is 6. Add 6 to that. 7348. Add 6 to that. You get 7354. 7354. Or this one. Now add the two values. You get 1.7354. We'll try to use index notation. How can we write down this one? This is 5.437 10 to the power 1. Then refer the table 5437. You get the same answer. 0.7354. That means 10 to the power 7354. 10 to the power 1. Same base, different powers multiplication, you can add the power. So 10 to the power 0.73, here 1 point. Adding powers, you get 1.7354 is this number. When you take log value, LG of 54.37 is this number, 1.7354. So you can use either laws of logarithms or index laws to find out the logarithmic value. Example number 2. Find the logarithm of each of the following numbers. These numbers are the same thing. So you get the same mantissa value. Only difference is the characteristic. So first we'll look at the characteristic. How we get the characteristic? Look at the number. This is 8 point something. So characteristic is 0 point value. 85, 1 point something. 858, 2 places to the right, 2 point something. Here 1, 2, 3. 3 point something. That's how you find out the characteristic. Now we'll look at the mantissa value. 85, 83. 85, 8, 3. 3 is 2. Adding 2. 9337. 9337. That's the mantissa value, 9337. So that's the log value. Straight away you can write down the log value. If you write down separately, I can write 8.583 is equal to 10 to the power 0. Then this one 10 to the power 0.9337. And LG value. LG of 8.583 is this value, the logarithmic value of this. This is LG 85.83 is equal to 1.9337. LG of 858.3 is equal to 2.9337. LG of 8583 is equal to 3.9337. Example number 3. Find the logarithm of each number using the logarithms table. Write each number in index form too. 69.34. How can we find out the log value? We know that this is 10 to the power 1. So you get LG of 69.34 is 1 point something. What's the mantissa value? 69.34. 69 from this table. 3 is this one. 4, we need to look further. 4 is 2. So add 2 to that, 69. So 84, not 9. 84, not 9. So how can we write in index notation? 69.34 is 10 to the power 1.8409. This one, LG of 957.1 is equal to what's the characteristic? 1, 2. So 2 point something. 9571. 95, 7. 95, 7. 1. 1 is 0. You get 9809. 9809. Then we can write the number. 957.1 is 10 to the power 2.9809. This one, 1248. So what's the characteristic? When you take log, characteristic is 1, 2, 3. 3 point something. 12, 4, 8 from the table. 12, 4, 8. I'll refer with this one. 12, 4 is this value. 12, 4, 8. 8 is 28. Add 28 to that. 0, 9, 34, 28. You get 0962. So the mantissa 0962 is the mantissa value. Then how can you write down the answer? 1248 is 10 to the power 3.0962. Exercise 20.3. Find the logarithm of each of the following numbers using the logarithms table and write the numbers in index form too. 59.1. LG 59.1 is, characteristic is 1 because moving one place to the right. 59.1, refer from the table. Here 59.1 is 7716. 7716. Then you can write 59.1 is 10 to the power 1.7716. This one, what's the characteristic? 1, 2. 2 point something. 1002. 1002 from the first table. 1002. 2 is 8. So what's the number? 0008. Then if you take this is LG number. I can write 10 to the power. This one is this. LG is LG of 100.2 is 2.0008. So what's this number? 10 to the power here, one place to the right, 1 point something. 9541. 9541. 1 is 0. You get 9795. 9795. So what's the LG value? LG value of 95.41 is 1.9795. Now write down these numbers in index notation as well as log value. This is straight away I can write 10 to the power. What's the characteristic? 1, 2, 3. 3 point something. What's the characteristic here? 1, 2. What's the characteristic here? 1, 2. 2 point something. Now find out the mantissa value using the log tables. 14, 1, 2. 14, 1, 2. 14, 1, 2 is 6. So 1498. 1498. So what's the log value? LG of 1412 is 3.1498. Now here, this one 59 to 1. 51 to 1 from the second table. 59 to 1. 59 to 1 is 1. So 77, 24. 77, 24. So you can write LG of 592.1 is 2.7724. Next one, 890. 890, 9494. Then what's the log value? Log of 890 is 2.9494. Now look at the second question. If 10 to the power this is given 7.832, find each of the following values. Now same number here. So what's the log notation? We can straight away write down log of this value is equal to 0.8939. That's the conversion of index notation to log notation. Now look at this one. 7832. Same value, but earlier this is 7.8, now 78.32. That means what's the characteristic? Here you need to put 1. You get 1 point. Same mantissa value. 8939. So the value is 1.8939. Look at this one. What's the characteristic? 1, 2, 3. 3 point. 3 is the characteristic. What's the mantissa? Same mantissa because you get the same number. 8939. Example number 1. Find anti-log value of 0.8436 using the logarithmic table. So how can we find out anti-log? 8436 from the table. 8436. Search where you get 8436. 8432 is there. To get 36, you need another 4. You can refer from here. What's the number? 6976. 6976. 6976 is the value. Now we need anti-log of 0.8436 is equal to, now here look at this value. The characteristic is 0. That means the number is less than 10. 6.976. Example number 2. Find the value of anti-log 1.8436. Now the characteristic is 1. Earlier, you got the characteristic 0. So, what's the number we referred before? 6976. So, here also you are getting 6976. Now, the characteristic is 1. So, that means you have to move one place to the right. The answer is 69.76. Example number 3, find using the logarithms table anti-log value. So the characteristics are different and same mantissa value. So you have to refer where you get 5432. 5432. We'll see from the first table where you get 5432. 5428 is there. 32 means you need another 4. So you get 3493. 3493 is the anti-log value. 3493. Now the characteristic is 1. That means you are moving decimal place one place to the right. Answer is 34.93. This one, same mantissa value. You get 3493, but the characteristic is 2. 2 places to the right, 349.3. Same mantissa. Characteristic is 3. 1, 2, 3. So 3493. Exercise 20.4. Find the following values using the logarithms table. Anti-log of 7350. So where we get 7350. So definitely the first table. So we'll look at the first table. 7350. 7350. Here 48 is there. You need another 2. That's 2. 5432. 5432. This is 0 point. 0 is the characteristic. The number is less than 10. 5.432. The next one, 2.4. So 4th, you look at the mantissa value. 4337. 4337. 30 is there. You need another 7. So you can take 6. 27, 1. 27, 1, 4. 27, 1, 4. And the characteristic is 2. That means you are moving 2 places to the right. The decimal place is here. So what's the answer? 271.4. Next one, anti-log of 3.5419. 5419. Look at the first table. 5419. Look at carefully. 1, 6 is there. You need another 3. That's 2. 3482. 3482. Characteristic is 3. That means you are moving the decimal place 3 places to the right. 1, 2, 3. Answer is 3482. This one, anti-log of this. Characteristic is 1. Mantissa is 0072. Look at the table and see where you get anti-log of 1.0072. Look at the mantissa, 0072. 0072 is here. we have 43. When you subtract 43, you need 29 more. Here 7 is the answer. So it's 10, 1, 7. 10, 1, 7. Characteristic is 1. So 10.17 is the answer. Next one. 2.9114. Mantissa is 9114. We'll look at the second table. 9114. Here 112 is there. So you need another 2. That means 3. 81, 5, 3. 81, 5, 3. Characteristic is 2. Move 2 places to the right. 815.3. Next one. 84, 8413. This is antilog. So you have to look at the antilog value. 8413. 8414 is there. 8407 is there. You need another 6. Another 6 from 9. 69, 3, 9. 69, 3, 9. Here the characteristic is 3. Move 3 places to the right. 6939. Question number 2. If LGX is this one, find the value of x. So logarithmic value is there. So how you find out x? We have to take the antilog. So x is antilog of 0.7845. Now we need to find out the antilog value. 7845. So we'll check 7845 in the next table. Second table 7845. 7845. 46 is there. So 39. You need another 6. 8. 60. 8. 8. So value is 60, 8, 8, but here the characteristic is 0. You get 6.088. Now here, look at the next one. Find the value of x by expressing antilog of 1.7854. Here, this should be 1.7845. Now the characteristic is 1. We found out now antilog of this one is 6.088. Same Mantissa. You can write down antilog of 1.7845 is, when you refer the table, you get the same value, but the characteristic is different. That means the answer is 60.88. The next one, find the value of antilog of 2.78. Here also 2.7845. You can't do using this information if this is 5.4. So what's the antilog value? Now the characteristic is different. You can write down this one as same value 6088, but 2 places to the right. 1, 2. So the answer is 608.8. Now last one. 7845. So same Mantissa value, you get the antilog, same thing. So log of this is this. So antilog 10y is equal to antilog of 0.7845. So what's the value? Antilog of this? We found 6.088. 10y is equal to this, and what is y? You need to divide this by 10. Divide by this by 10, you get 0.6088. Example 1 in your textbook, evaluate using the logarithm table. Now you get multiplication. So how we can solve this using log tables? You have to convert to logarithmic value. So we'll take this one as a letter A, 4.975 multiplied by 10.31. So when you take log both sides, what happens? Log multiplication becomes addition of logarithms. I can write LG 4.975 plus LG 10.31. Addition of logarithms. So when you add logarithms, you can find out the LGA value, and when you take the antilog, you can find the A value. Now LG 4.975 means 49.75, 49.75. 5 is 4. So 69.68 is the answer. So here 69.68. So this is less than 10, you get 0.6968. Then the next number 10.31. 10.31 is 4, adding 4 to that 0.132. 0.132. This is 10.31. So what's the characteristic? You get 1 point. 0.132. Now add the log values. 0.6968, 1.0132. When you add, you get 1.7100. That's log value of A. How we can find out A? Log value of A is 1.71. What's the antilog value? That's A. When you take antilog of 1.7100, you get the A value. So characteristic is 1. You have to refer 7100. 7100 in the first table. Here 93 is there. You need another 7. 7 from 8. 51 to 8. What's the value? 51 to 8. And the characteristic is 1. So move one place to the right. So 51.28 is the answer. We discussed the answer using log method. Now we'll try to use index notation. When you use index notation, what happens here? A is 4.975 into 10 to the power 10.31. Now we can use logarithmic table and write down what is 49.75. We found out 6968. 6968. And what's the logarithmic value of 10.31? 0.132. And here this is 10. That means 1.0132. Then same base, different powers multiplication. You add the powers. This becomes 1.0132. 0.7100. Then if this is A is this one, how we find out the value? You use the antilog. This is same as antilog of 1.7100. Then you refer the table and get the antilog value. So you can use index notation as well as the log notation. We'll take this example. 53.21 divided by 4.9. So we'll take this one as A. And take log both sides. Division, what happens to the logarithms? Subtraction. LG 53.21 minus LG 4.97. Now refer the table. 53.21. 53.21, what's the log value? 53.21. 1 is 1. So 72.60. 72.60. This number is more than 10. The characteristic is 1. So the log value is 1.7260. This number 49.7. 49.7 is 69.64. And the characteristic is 0. Now we'll subtract these two. 6, 4, 10, 1 remaining. 7 and 9, 16, 1 remaining. 10, 2, 1 remaining. 1. So you get 1.0296 is LG of A. Then how can we find out A? Antilog of this value. Now refer the table and find out where you get 0.296. 0.294 is there. You need another 2. So the minimum is here 4. You have to add 1 to that. So 10, 7, 1. 10, 7, 1. So the characteristic is 1. What's the number? 10.71. Now we'll look at how we can use index notation to do that. So I can write same thing here, 53.21 divided by 4.97. Now we'll try to write down this one in base 10. So 53.21 is 10 to the power 1 point. Refer the table 53.21 and we get 7260. Divide by 10 to the power. How can we write out 4.97? 49.7. Refer 49.7 and you get 6964. Now use laws of indices. Same base, different powers, division. You subtract the powers. When you subtract the powers, you get 1.0296. Then take the log value, the anti-log value, because A is this one. So we can write down this one as 10 to the power 1 times 10 to the power 0.0296 and this is 10 times, use the value when you take the antilog value of this one. We can find out from the table, that's 1071. 1071, but this is characteristic is 0, that means 1.071 multiplied by 10, you can get 10.71. So we use two methods, either using log method or index method. But which one is easy? Log method is easier than index notation. We'll take example 2. Using the logarithms table, find the value of this. Now we need to take this one as a letter A and take log both sides. When you are taking log value, what happens? Multiplication becomes addition, division becomes subtraction. So I can straight away write down this one as 594.2 plus LG 9.275 minus LG 84.21. Now look at the table and find out the logarithmic values. 5942. 5942, second table. 5942, adding 1, 7739. 7739. And what's the characteristic? 2 places to the right. So 2.7739. This number 9275. 9275. 5 is 2. 9673. 9673. Characteristic is 0. So 0.9673. Here 8421. 8421 is 1. 9254. 9254. This is characteristic is 1. Now we can add the logarithmic values. 2.7739, 0.9673. Add it together. You get 1 remaining, 7 plus 7, 14, 1 remaining, 17 and 3. And then subtract this value. When you subtract, you get 1 here and 9 plus 8, 17, 1 remaining, 2, 3. 1.8158. 1.8158. Now how can we find out the A value? Antilog. A becomes antilog of 1.8158. Look at the table and see where you can find 8158. 8158. 6 is there. Then another 2. That means you have to add 3. 65, 4, 3. 65, 4, 3. So characteristic is 1. Move 1 place to the right. 65.43. Exercise 20.5. Find the value using the logarithms table. So here what we do, take a letter as this question. We'll use laws of logarithms. Take log both sides. Multiplication becomes addition of logarithms. So straight away I can write LG this plus LG this one. Then look at the table. 54.3. First table. 54.3 is 73.48. And that's a mantissa. What's the characteristic? 1. Then the next number, 17.5. 17.5 is 24.30. 24.30 and the characteristic is 0. Now add the two values. You get 1.9778. To find out A, you'd have to take antilog of 1.9778. Use the table and see where you can find 9778. 9778. 77 is there. We need one more. So 2. 9502. 9502 and the characteristic is 1. The answer is 95.02. Look at the next one. Take this one as A. This is multiplication. Multiplication becomes addition of logarithms. Log of A is LG 323.8 plus LG 2.832. Now we'll look at log value of 3238. 3238. 3238. 3 is 5092. 8 is 11. 50 92. 50 92. And adding 11. So you get 5103. 5103 and what's the characteristic? 2.5103. Then the next one 2832. 2832. 2 is 3. So 45. 18 plus 3, you get 21. 45, 21. 45, 21. And this is characteristic is 0. Now add these two values 2.5103, 0.4521. You get 2.9624. When you take antilog value, you get the A value. Refer the table and see where you get 9624. 9624. Here exactly you are getting that number 91.7. 91.7 and the characteristic is 2. You move 2 places to the right, 970. Take this one. You get 3 numbers. So same as before. When you take log both sides, you are adding all these log values. So I can write all addition and now we'll refer the table. 54.1. 54.1 7332. 7332, and the characteristic is 1. Now 2715. So refer the table. 2715. 27 is this one, and 5, 2715. 5 is 8. You need to add 8 to that. 4338. 4338, and this is 27. Characteristic is 1. The next number 43. So 43 0. 43 0. 6335, and characteristic is 1. Now add all the decimal values. 1.7332, 1.4338, and 1.6335. When you add, you get 15 here, 1 remaining, 10, 1 remaining, again 10, 1 there, 18, 4.8005. So take the antilog of this value is 8005. 8005 from this table. Here 8007 is there. Here 8000 is there. 8005. You need another 5. That's 7. 6317. 6317. 6317. The characteristic is 4. So 4 places to the right. 1, 2, 3, 4. So the answer is 63,170. Now we'll take the next one, division. Straight away I can write down LGA is subtraction of logarithms. Now refer the table 5232 and 9375. 5232. 52 3 is this one, and 2. 2 is 2. So 7187. 7187. This is 2 places to the right. Characteristic is 2. 9375. 93 7. 7 is this one. 5 is 2. 9719. 9719. Characteristic is 1. We need to subtract the two values. 2.7187, 1.9719. Subtract, you get 8 and 6 here, and 4, and for 16 that's 7. So 0.7468. 0.7468. Antilog value of that is 7468. Look at the table. 6 is there, so you need another 2. 5582. 5582. The characteristic is 0. Answer is 5.5582. Next one. Both these questions you have to take A as this number and then take log. I'll straight away write down log of A is log of 43.17 minus log of 8.931. This one I can write log of A is LG 73.1 plus LG 25.41 minus, because division becomes subtraction. Now we'll try to find out the log values. 43.17, 43.17, 7 is 7. So adding 7 to 63.45, 63.52. This is 43, so the characteristic is 1. 89.31, 89.31. 1 is 0, 9509. 9509. Check it again. 9509. Now the characteristic is 0. Now subtract. 1.6352, 0.9509. When you subtract, you get 4 here, 0.6843. So 6843, refer the table. First table, 6843. 68439 is there. You need another 4. Another 4 from fourth one. 4834. 4834. Antilog of this is 4834 and the characteristic is 1. So the answer is 4.834. So I can write the answer is 4.834. Now we'll take the next one. We'll refer the table. 73.1. 73.1 from the table. 73.1. 86.39. 86.39. Characteristic is 1. 25.41. 25.41. 1 is 2. So 40.50. 40.50. So you can write down 40.50 and the characteristic is 1. And 18.32. 18.32. 18.3 is this. 2 is 5. Adding 5. 26.30. 26.30. And what's the characteristic? 1. Now add these two. You get 3.2689 and subtract the other number. .0059. Now take the antilog to find out the solution. 0059 from the first table. 0059. 43 is there. 59 minus 43. You need another 16. So another 16 you can get it from closest value is 4. 10, 1, 4. 10, 1, 4. So the answer is 10, 1, 4. And the characteristic is you're moving 2 places to the right. So the decimal point is here. So the answer is 101.4. Now take this one again, multiplication and division. You can straight away write down adding when it's multiplication of logs, and you can subtract when it's division in logs. Now refer the table and find out the log values. 8572, and here we'll do 2973 first because we have to refer the first table there. 2973. 2973. 3 is 4. So you get 4732. 4732 for this one. Characteristic is 1. Now we'll refer the second table. 8572. 8572. 2 is 1. 9331. 9331. And the characteristic is 1. 581. 7642. Characteristic is 1. Now add these two. You get 3793. So 3 point this and then subtract 1.4732. When you subtract, you get 4222. 2.2241. Take antilog. You can refer from the first table. 2241. 27 is there. You need 41. When you subtract, you need another 14. 2241. 27 is, you need another 17, another 14. That's the closest value is here. That's 1675. 1675 is the answer. So 1675. The characteristic is 2. So that means 167.5. So the answer is A equal 167.5. Now we'll look at question number 8. Multiplication and division. Do the same thing. Log of A is addition of the first two numbers and subtract the division value. Subtract the value in the denominator. Now refer the tables. Now these two, second table, and this is first table. We'll refer the first one. 11, 2, 8. 11, 2, 8. 8 is 11, 2, 8. I'll mark here. 11, 2 is here. 8 is 30. Add 30 to 0492. You get 0522. 0522. The characteristic is 2.2. Then 73, 45. 73, 4, 5. 73, 4 and 5 is, I need to see the number properly, 40. 73, 4, 5. 73, 4, 5. 5 is 3. Adding 3 to that, 86, 60. 86, 60. And the characteristic is 1. Next one, 82, 1, 1. 82, 1 and 1. When you refer 1, you get 1. So 91, 44. The characteristic is 1. Now add the two log values, 2.0522, 1.8660. When you add, you get 3.9182. When you subtract 1.9144, what do you get? 2.0038. When you take antilog, you get the A value. So 0038 from the first table, 0038. 43 is there. 38 you can get it from 9. 1009. 1009, and the characteristic is to move 2 places to the right. So 100.9. Now we'll look at this question. First we'll look at A as the question and take log both sides. You get LGA is equal to LG 953.1 plus, because this is multiplication, 457 minus LG 23.25 minus LG 99.8. Now we'll refer the table 9531. 9531 from this table, refer that 9531. 95.3 is here, 3 and 1. 1 is 0, so you need to get this number, 97, 91. This is 2 places to the right. So what's the characteristic? 2 is the characteristic. Now this number 45, 7. 45, 7, we have to use the other table. 45, 7. 45, 7 is this number, 65, 99. 65, 99 is the number, and this one is 400 and something, 2 places to the right, 2.6599. Now the next one, 2325. 2325 from this table, 23, 2 is this, 5 is 9. Add 9 to this one, you get 64, 36, 64. 36, 64. And this is just one place to the right, 1 point. And what's the other number? 99, 8. So refer the other table, 99, 8. 99, 8 is 9991. So I can write 9991 and here 1 place to the right. So that means 1 point. 9991. This is negative. Now we'll look at the question, and here we need to add these two together and subtract. So we'll add these two together. 2.9791, 2.6599. When you add it, you are getting 5.6390. When you add these two together, what you get? 1.3664, 1.9991. When you add it together, 3.3655. So now we'll subtract. 3.3655, subtract, you get 5 here. 8 minus 5, 3. And 5 minus 3, 2. 5 minus 3, 2. So you get 2.2735. Now we have to take antilog to get the value A. So antilog of this number is, we'll look at the table 1, 27, 35. 27, 35. 27, 35. 27, 18 is there. So 18 is there, we need 35. When you subtract, you get 17. So we need another 17. So where you get 17? 16 is there. So 7. 18, 7, 7. 18, 7, 7 is the antilog value. 18, 7, 7. But here the characteristic is 2. That means 2 places to the right, 187.7. Question number 2. The circumference of a circle is given by formula C equals 2 pi r. It is given that pi is 3.142 and that r value is 10.5. Find the value of C using the logarithms table. So this is C. So when you take log of C, you get log of 2 plus log value of 3.142 plus log value of 10.5. Then refer the table. 20, 0. 20, 0, you get 30, 10. And the characteristic is 0. 31, 42. 31, 42. 2 is 3. So you are adding 3 to that. 49, 72. And this is 3 point. The characteristic is 0. Then the next one is 10, 5. 10, 5, you get 0, 2, 1, 2. 0, 2, 1, 2 and the characteristic is 1. Now add all these log values together. 4, 9, 7, 2, 1.0212. When you add, you get 4, 9. 1 remaining, 8, 1.8194 and when you take the antilog, you get the C value. So 8194. Antilog of this one, 8194. 8194. Here you need 81. 89 is there. 94. To get 94 you need another 5. That's 7. 65, 9, 7. 65, 9, 7. The characteristic is 1. The answer is 65.97. We'll take the next one. Next question. Area of the curved surface of a cylinder is given by A equals 2 pi RH. You have given all the values. Pi is 3.142, R is 5.31 and H is 20. Using logarithms, find A. So all these multiplication, so log value becomes addition. Now refer the table. 20, 0, 20, 0, 30, 10. Here also 20, 0, 30, 10. The characteristic is 1 here. Characteristic is 0. 31, 4, 2. 31, 4, 2. 2 is 3. Adding 3, you get 49, 72. And characteristic is 0. And 53, 1. 53, 1 is 72, 51. 72, 51 and the characteristic is 0. Now add all these values. You get 5, 1.3, not 10. Then when you add all together, you get 3 here. 7 plus 5, 12. 13, 14. 1 remaining. 10, 12. 1 remaining. 11 plus 4, 15 plus 3, 18. 1 remaining. 2.8243. Take antilog value. A equals antilog of 2.8243. Now look at the second table. 8243. 8243. We'll look at the table. 8243. 8243. 41 is there. 43, you need another 2, that's 3. 66, 7, 3. 66, 7, 3. 66, 7, 3 and this is 2 places to the right. 1, 2. So the answer is 667.3. Now we'll look at how we can use the calculator to find out the solutions. So this is a basic scientific calculator and this is Casio, and different calculators give different functions, keys. Now in this class, you need to know just multiplication, division, addition, subtraction. So all these functions are the same in all calculators. So multiplication is this button and division we use this one, and addition is plus and subtraction minus. And when you get a big expression, sometimes you need to put brackets. So brackets in these two functions, you get brackets. So when you take a calculator, first step is to switch on the calculator. So on button is there. So after that you can enter the values, and for decimal you can use the dot there. So we'll try to use the scientific calculator to find out the solutions without using the logarithm table. Now we'll take first example. Write down in order the keys that should be operated to perform each of the following calculations using a scientific calculator. Write down the result that appears on the screen too. So here these are basic addition. We'll try to first write down the keys. So what's the first step we have to do? Switch on the calculator and then enter the numbers. 4, 6 and then plus sign 1, 2, 7 and then equal sign to get the answer. So we'll do the calculation. 46 plus 127, 173. This one 59. First switch on the calculator and here all these use arrows. This is the process. And switch on the calculator, then enter the number 5, 9, then subtraction, use this symbol, 2, 7 and then equal sign. What's the answer? You get 59 minus 27. Calculator gives 32. Next one. Now point is there. So on 5.4 plus 4.1 minus 0.7. You can put point also or 0 as well. 0 point and then 7. Press equal button. You get the answer. 5.4 plus 4.1 minus 0.7, 8.8. Now this one on 7.5 multiplied by, the next digit is 2 and then 3 equals. And we'll write down this and then use the calculator. This is on. Now can you see? You have to first do this expression. There are brackets. So you have to put brackets. So you have to open a bracket. And then type 2.7 plus 4.2.3 42.3, then close brackets, this bracket, and then divide, division sign, and then 1 and 5, then equal sign to get the answer. Now we'll try both these answers using the calculator. So first one, 7.5 multiplied by 23, 172.5. What's the calculator answer for the other one? Open a bracket, open a bracket, 2.7 plus 42.3, close brackets, divide by 15. You get 3 as the answer. Exercise 20.6. Write down in order the keys of the scientific calculator that need to be used to perform the following calculations. Write down the result that is obtained on the screen too. So we'll first write down the keys. First start with on. Then you can do at once, no need to use brackets because calculator automatically gives the multiplication first when you type like this. So I can first just type 5, 4, 3 plus 2, 7, 5. Multiplication, then 1, 7, then equal sign. I'll write down the second one also, all the keys. Switch on the calculator. 2003. 2003 minus 125. So 125. 125 multiplied by 3. Then use the equal sign. Now we'll see how we can find out the answer. So 543 plus 275 multiplied by 17. 5218. Now we'll do the next one. 2003 minus 125 times 3. 1628. These calculations, first we'll write down all the keys. On 2, 5, point is dot 1, and then addition 3.04. 3.04. 3.04 divide by 1.1, then equal button. This one, switch on the calculator. 5, 7.3 multiplied by 1.75. 1.75 plus 45.3 and then equal sign. This one, switch on the calculator. 49.5 divide by 15. 15 plus and then 12. 12 and then equal sign. This one you get brackets. That means this one first. So you need to put brackets. open a bracket, and then 32.1 multiplied by 4.3. 4.3, and then close brackets, plus 1.5. 1.5, and then equal 1. Now we'll see what are the values. So here first one, 25.1 plus 3.04 plus, no, not plus, divide by 1.1. 27.86. So you get several digits. I'll write 4 like 27.8636. And the next one, 57.3 multiplied by 1.75 plus 45.3. 145.575. Next one, 49.5 divide by 15 plus 12. 15.3. Last one, you need to put brackets. Open bracket, 32.1 multiplied by 44.3, close brackets, plus 1.5. 139.53. Now we look at question number 2. Simplify each of the following expressions using the logarithms table. Find the value of each expression using a scientific calculator too. Examine up to which decimal place the values obtained by the two methods are equal. So we'll first use the log method. We'll take this one as A and taking logarithms. I can write this one is addition of logs. Then refer the table. 42.7 is 63.04. 63.04 and characteristic is 1. 39.25. 39.25. 5 is 5. So 59.38. This one characteristic is 1. Add the two values. You get 3.2242. When you take the antilog, you get the A value. 2242 from this value. 2242. 27 is there. 42 minus 27, you need another 15. Another 15, closest is 16. Take the highest value. So 16.76. 16.76. And this is 3. Characteristic is 3. Move 3 places to the right. 1, 2, 3. 1676. Now we'll use the calculator and see what's the calculator value. Calculator, When you use the calculator, you get 1675.975. Now, up to which decimal place is correct? Now, when you take to the units place, you get 1676. So, to the nearest unit place, this is the same. So, we can see to the nearest units place, the values are equal. Now we'll look at the next one. 514.1. So again, divide by 31.7. You can take log of A, log of 514.1 minus log of 31.7. Use the table. 51, 4, 1. 51, 4 is this one. 1 is 1. So 7, 1, 1, 1. 7, 1, 1, 1. This is 2 places to the right. Characteristic is 2. 31, 7. 31, 7 is here. 50, 11. 50, 11. The characteristic is 1. Now subtract the two values. You get 1.2100. When you take the antilog value, you get the A value. 2100. 2100. Here 2095 is there. So you need another 5. Another 5 from here. 16 to 2. 16 to 2 and the characteristic is 1. So the answer is 16.22. Now we'll use the calculator. 514.1 divided by 31.7. 16 point. Calculator gives 16.2176 like that. Now, which decimal place it is correct? If you take second decimal place, you get the same answer. So, we can write correct to second decimal place. You get both the answers equal. Next one, we use logarithms. Log of any value is log of 372.1 plus log of 4.3 minus log of 59.25. Use the table. 37 to 1. 37 to 1. 37 2 and 1 is 1. 5706. So you get 5706 and here 2 places to the right. So the characteristic is 2. Then 430. 430 again. 430 6335. 6335. 6335. Characteristic is 0. So this is plus. And the next one is 5925. 5925 is from this table. 59.2 and 5 is 4. 7727. 7727. And this is 1 is the characteristic. Now we'll add these two and subtract the other one. 2.5706, add 0.6335, you get 1, 4, 10 and 12. So 3.2041, subtract 1.7727. You get 4 here, 3 minus 2, 1, 10 minus 7 is 3, and this is 11, 11 minus 7 is 4, and 2 minus 1 is 1. 1.4314. Now take antilog value to get A. A is antilog of this value. So 4314. 4314 from this table, 4314. It's already there. 27 0. So 27 0. And this is one place to the right. So you are getting 27.0. So that's the value from the table. Now we'll look at the calculator value. Calculator value gives 27.0047. Now we see correct to one decimal place, you get the correct answer. So this answer is significant, correct to one decimal place. Use logarithms. Log of this value, we can add it first and subtract the denominator value. Now refer the table. I'll refer these two first. 14 0, because that's first table. 14 0 is 1461. 1461 and characteristic is 0. Then 10 1 5. 10 1 5. 10 1 5. 5 is 21. Add 21 to 43. You get 0064. 0064, and this is two places to the right, 2.0064. Now we'll refer the second table, 75 3. 75 3. 87 68. 87 68, two places to the right, 2.8768. Now we'll add these two values. .0229 and subtract this value. .0165. Take the antilog. 1.0165. Use the table. 0165. 0165. 70 is there. We'll see which one is closer. 0165. So 28 is there. We'll see. We need 37 more. We'll see whether we can get 37. Yes, that's 9. So what's the answer? 43 you are getting from 21. So here you get 10, 3 and 9. 10, 3, 9. And characteristic is 1. So the answer is 10.39 when you use the logarithms. Now we'll use the calculator and see. Calculator gives 10.3862. Now we'll see correct to second decimal place. This is correct. So we can write correct to second decimal place. These two values are the same. This question we'll use logarithms first. Here first we need to add log values and then subtract the other log value. So refer the table. 12, 5, 12, 5, 0, 9, 69, 0, 9, 69. Characteristic is 1. 62, 4. And we'll use the next one because same table. 25, 3, 2. 25, 3, 2. 2 is 3. So adding 3, 40, 34. This one is 40, 34. And the characteristic is 2. Now we'll refer the second table. 62, 4. 62, 4 is this number. 79, 52. 79, 52 and the characteristic is 1. Now add. Now subtract these two. You get 7, 4, 11, 1 remaining. 4, you get 8, 12, 1 remaining. 8, 4, 0. So 0.4887. Take the anti-log value of 0.4887. 4887. 86 is there. You need one more. 30, 8, 1. 30, 8, 1 and this is 0. That means 3.081. The answer is 3.081 using the logarithmic tables. Now we'll see how we get the value. So the calculator value. Use the calculator. You get 3.08056. Now see, correct to this decimal place, it's correct. So 1, 2, 3, correct to third decimal place. We'll write correct to third decimal place. It's the same value. Miscellaneous exercise. Find the value of this. Now, you don't need logarithmic tables. So, you can straight away use laws of logarithms. Addition becomes multiplication. And can we do that? These are different bases. So, you can't use laws of logarithms. But we can simplify this one. Log 4, 65. 65 is 4 to the power 3. What about this one? 81, 3 to the power 4. This is 5 and 5 plus 1. Now what can we say about this one? Here, can you remember? 10 to the power 1 is 10. Then, if you write in log notation, log 10 base 10 is 1. Same base, same number, you are getting 1. Now here, when you take this one outside, what you can write? 3 log 4 base 4 and 4 log 3 base 3. You can straight away write down the answer. What's log 4 base 64? You get 3 as the answer. What's the log 3 base 81? You get 4. And what's this one? Log 5 base 5? You get 1. And adding 1. Now when you simplify, you get 7 as the answer. Find the value of each of the following expressions if log 6.143 is this. So you have given log value given. Now you are asked to find out 10 to the power 7884, same value. So what's 10 to the power this? You get 6.143. Now the characteristic is different now. You can write this one as 10 to the power 1 into 10 to the power 0.7884. We know that value is this. So 6.143 multiplied by 10. 61.43. This one 2 point. That means 10 to the power 2 times 10 to the power 0.7884, 100 times 6.143. When you multiply by 100, you get 2 places to the right, 614.3. Question number 3. Find the value of each of the following expressions. 10 to the power, this is given 4.552. Now, that's the index notation. When you write in log notation, log of 4.552 is same as 0.6582. Then log of 45.52, how can we do that? This one I can write log 4.552 multiplied by 10. So log of this value is 10 to the power 0.6582. And you get log 10 to the power 1. So when you are using that one, we can write down. This is addition. When you add these two, what you get? 1.6582. What's the log of 45.52? Log of that value is 1.6582. Now same thing. How many places move? Now this is, we can write 4.552 multiplied by 100, 10 to the power 2. That means same mantissa value and you get the characteristic different. So we get 2.6582 as this value. Question number 4. Find the value of each of the following expressions if antilog is antilog 1.6443 is given 44.08. Now you need this one. Only the characteristic is different. Same mantissa. So what is the answer? You get 4408, but now this is 0. 0 means the answer is 4.408. Here same mantissa. The characteristic is 2. So what's the answer? 4408. Characteristic is 2 means 2 places to the right. Move the decimal place 2 places to the right. 440.8. This one, same mantissa. 4408. 3 places to the right. So 4408. Question number 5. If LGA is x, LGB is 2x, express LGAB. Log multiplication becomes addition. Log A plus log B. Log A value is x, log B value is 2x, x and 2x becomes 3x. Second part, if LGX is 0.9451, LGY equals 0.8710. Find LGX over y. LGX over y we can write as subtraction of logs. Then you can substitute 0.9451 minus 8710. We'll subtract here. You get 0.0741. Look at this question. Again, you can take as this as A and take logarithm both sides. You get LGA is equal to LG 38.72 plus LG 1.003 minus LG 5.1. Now look at the table. 38.72. 38.7 is this one. 2 is 2. So 58.79. 58.79. Characteristic is 1. 1 point. Next one, 10.03. 10.03. 10.03 is 12. Add 12 to that, 0, 0, 12. And the characteristic is 0. Next one, 51.0. 51.0 is from this table. 51.0, 70, 76. 70, 76. And the characteristic is 0. Now we'll add these two and subtract the other one. 1.5879, 0.0012. Add it together. 1.5891. Now subtract the other number. 0.7076. 0.8815 when you take antilog of this, you can get the answer. So antilog of 0.8815. 8815. 14 is there, you need another one. 7611. 7611 is the 76, 1, 1, and the characteristic is 0. So the answer is 7.611. Now we'll look at the calculator. The calculator answer is 7.6149. So correct to 2 decimal places. This is correct answer. So both are the same, correct to 2 decimal places. Now we'll take the next question. Again, same thing you need to do. Take logarithm, both sides. You get LG 5.432 plus LG 989.1 minus LG 379.1. Use the table 54, 3, 2. 54, 3 and 2 is 2. 73, 50. 73, 50. So the characteristic is 0. 98, 91. 98, 90, 1 is 0. 99, 52. 99, 52. Characteristic is 2. 37, 91. 37, 91. 9 is this one, 1 is 1. 57, 87. 57, 87, and the characteristic is 2. Now we'll add these two together. 0.7350, add 2.9952. That's 3.7302. Subtract 2.5787. 1.1515. Now we'll take antilog to get A. Fifteen, 15. We'll look at the first table. 15, 15. Here, 1492. 15, 15, 1492. When you subtract, you need another 23. 23 more. That's this number. So closest value you can take as 8. So 14, 8, 14, 1, 8. 14, 1, 8. Characteristic is 1, so you have to move one place to the right. Answer is 14.18. Now we'll see what's the calculator value. Calculator value is, calculator gives 14.1724. Correct to 1 decimal place, it is the same. So we can write correct to 1 decimal place. Correct to 1 decimal place. Answers are the same. This part, again, you can take logarithms to solve this problem. We can subtract the denominator values when you are using logarithms. Now we'll refer the table. 7858. Now we'll refer the tables. So we'll first refer 7858. 7858. 7858. 8 is 4. So adding 4 to that, 53. 89, 53. 89, 53. What's the characteristic? 2. 27, 2. 27, 2 from the first table. 27, 2. You get 43, 46. 43, 46. What's the characteristic? 1. 38, 0. 38, 0. 5798. 5798. Characteristic is 0. We'll first add these two. 1.4346, 0.5798. Get this and subtract this value from this. So 2.8953 minus 2.0144. When you subtract, you get 0.8809 and take the antilog value of 0.8809. 8809. Zero 8 is there. 76 0 1. 76 0 1. And this is 0, that means 7.601 is the answer. Now we'll see with the calculator. So when you use the calculator, you get calculator value gives A as 7.60255. Correct to second decimal place. This is correct. So correct to second decimal place. Both these values are the same. We'll take this one. Same thing again. Take A as this number and take log both sides. Log A is equal to log 75.23 plus LG 131.2 minus LG 5.74 minus LG 95.2. Now look at log tables. 75 to 3. So when you refer the table, 75 to 3. 75 2 is this, 3 is 2. So 87 64. 87 64. Characteristic is 1. 13 1 2. 13 1 2. 2 is 6. 11 79. 11 79. Characteristic is 2. 51 57 4. 57 4 from this table. 57 4. 75 89. 75 89 and characteristic is 0. Then the last one is 95 2. 95 2 is 97 86. 97 86 and the characteristic is 1. Now we can Add these two together. 1.8764, 2.1179. 3.9943. Subtract these two, but before that we can add these two together. 2.7375. Now subtract. 1.2568. Now take antilog of 1.2568 to get the answer 2568. From the first table you can get 2568. Two, 5, 6, 8. Here 53 is there. 68 minus 53, you need another 15. So here another 15 you need. So we'll take 14, 18, 0, 6. So the value is 18, 0, 6. And the characteristic is 1. So the answer is 18.06. Now we'll look at the calculator value. So calculator gives 18.0624. Here correct to 2 decimal place. The two answers are correct. Correct to 2 decimal places. Both the answers are the same. We'll take this question. We'll take A as the question and take log both sides. You get LG. A is equal to LG 5.743 plus LG 83.21 plus LG 5.91 minus LG 12.75 minus LG 4.875. That's the question. And now we'll refer the table. 57.43. 57, 4 and 3 is 2. 75.91. 75.91. And here 0 is the characteristic. 83.21. 83.2 and 1 is 1. 92.02. 92.02. Characteristic is 1. Then 59.1. 59.1. 77.16. Characteristic is 0. And this one 12.75. 12.75. 5 is 17. Add 17 to 10.38. 10.55. So you get 10.55 here. And the characteristic is 1. 48.75. 48. 7 is this number, 5 is 4. 48, 7. So 4, you have to add 68, 79. 68, 79, and this is 0 as the characteristic. Now what we can do? We can add these 3 and these 2 separately and subtract. 0.7591, 1.9202, 0.7716. Add it together. Now add these 2 together. And subtract. .6575. So take the anti-log value to get the answer. Anti-log of 1.6575. So we'll look at which table? The first table, 6575. 6575. 71 is there. You need another 4. That's 4. 45, 4, 4. 45, 4, 4, and this is 1 is the characteristic, so 45.44 is the answer. Now we'll look at the calculator value. Calculator gives 45.4377. Now correct to 1 decimal place. The 2 answers are the same. So we can write correct to 1 decimal place. 1 decimal place. 1 decimal place. Both the answers are the same. The last question. So again we need to use logarithms. We can add the numerator values with logs. And subtract the denominator values with logs. Now we'll refer the tables. Now here, this value and this value from the first table. But we'll do separately, otherwise it will get mixed up. 57.3 first, then the second table, 57.3 is 75.82. 75.82. That's 570 something. That means 2 places. So characteristic is 2. 21.23 from the first one. 21, 2 and 3. 3 is 6. So you need to add 6. 32, 69. 32, 69. I'll write here 32, 69. That's also addition and this is 2 point. So the characteristic is 0. then 61 0. 61 0, 78 53. 78 53, the characteristic is 0. So this is the numerator value, so we need to add these two together. 3.8704. Now we'll look at the denominator values. 9875. 9875. 5 is 2. So 9945. Now we'll look at 9875. 9875. 5 is 2. So adding 2 to that, 9945. 9945. And this is 9 points, so the characteristic is 0. Then the next one, 5421. 54 from the first table, 5421. 54 2 and 1. 1 is 1. So 7341. 7341, and the characteristic is 1. Now we can add these two. You get 2.7283. Now subtract these two values. You get 1.1418, antilog of that value. One four one eight. 1418. So 1418 we need. 1399 is there. How many more you need? 19. So here you get 19 there. 1386. 1386, and this is 1 there, so the answer is 13.86 with logarithmic table. Now we'll use the calculator. You get the answer as 13.8617. So the answer is correct to 2 decimal places. We covered all examples and exercises in this chapter. Practice how to refer the log tables, and using the logarithmic table, try to simplify and find out the answers.